Hi guys, today's notes are on 4.4a. We're going to be factoring polynomials today. So we're going to be actually using methods that we have used previously to factor quadratics, which are expressions with x squared as your largest degree, to factor polynomials with degrees larger than 2. So the first thing we always try to check for is the GCF by finding a common monomial factor. Remember, mono is 1. So if you can divide everything by one term, right? This is x, x, and x. Please make sure that your next step includes a monomial. So since we have no solving, we're not getting rid of this x, the x stays, right? So there's going to be an x on the outside. And what's left when we take out one of the x's, which is the same as dividing, is x squared minus 4x minus 5. Okay. Now it's really dangerous to just look here and actually box it as your final answer, which is what I actually did on my previous attempt at this video. You want to always check if you can factor further. So at this point, you want to see what multiplies to -5 and adds to -4. Some of you guys are still using this organization method, right, with the multiply and add, and so you get -5 and +1. And so your final answer when you break it down, and that's why it says factor further than the video, sorry, is you're going to have an x minus 5, and x plus 1. And that is your final answer. Now, please be aware that it doesn't matter what order you technically write your factors in, but we like to write the monomial first. So if you have a single term, please write that in the front. Okay, we don't like to stick x in the middle. It's just standard practice. Okay, so let's do the same thing here. This one we're going to divide by y to the third power. Okay. I always look at the variable at the very end, so this one should always cancel out, if possible, right, if it's the same one. And then don't forget that there's also a 3 in the front that we should check. Can we divide by 3? And our answer is yes. Okay. So please write your GCF on the outside. And then what's left inside? 3 divided by 3 is 1y squared. And -48 divided by 3 is -16. The y's all cancel. And then we do our check before we box. Can we go further with this blue binomial? And notice this is a difference of squares. A squared minus b squared, right? And that becomes a plus b times a minus b. But it only works for squares, okay? And so this is like our pattern that we can remember. Okay, and those are b's, not sixes, sorry. So that means I have 3y cubed as my GCF. And then we have y minus 4 and y plus 4. So once again, please do a check and make sure that your final expression, if I decided to multiply it out, would become this. And it has that 3 in front, right? Because we took out the 3. The big mistake that I see students make is they lose their GCF. So this is divide by 5, 5, and 5, and I can take 2 z's out of each one. Strongly suggest you cross your z's because z's and 2's look very similar for some of you guys. So this will be z squared, right, because the 5's cancel. 2 of the z's are out. We will be left with 2 plus 6z plus 9. Okay. And for this one, I want you guys to be really careful. This 5z squared, this becomes z plus 3 and z plus 3. Please do not leave that as your final answer. Your final answer needs to be simplest form. And so that means you need to have z plus 3 squared. Okay. So, sorry, I totally forgot to read the directions, but you always check for GCF first, and you make sure each factor is written in standard form. So z, variables first, then numbers. Okay, variables first, then numbers. So let's keep going with special patterns. We touched on a special pattern for a difference of squares here, And now we're going to learn one for sum and difference of two cubes. So your formula for this, if you have something cubed plus something cubed, like we do here, so this is a equals 1, 2, 3, this is x times x times x, right? And this one is 5 times 5 times 5. That means in this term, I have a equals x and b equals positive 5. If you have this, and you notice that you have this pattern of cubes, then there is a formula that always works. I'm going to go a plus b, a squared minus ab plus b squared. Okay? And so just know that this sign changes. So if you have a positive b value, then here this middle term is going to be a minus. If this were a negative b value, this would be the opposite of a negative, which is a positive. So what we can do now is use our formula. Before we do that, can we do a quick check just to make sure that this actually works? Because what if I lied to you? Or what if I remembered the formula wrong? Okay, so a plus b, a squared minus ab, b squared. We can do positives. Okay, so a times a squared is a cubed. This a times a is negative a squared b. And then a times b squared is a b squared. Okay. And then this one is b times a squared. So we usually write a's first, a squared b, but that's positive. You guys see how these two cancel out? And then b times b is b squared with the a in front, and it's a negative. And now these cancel out. And then we have b squared times b is b cubed. Okay, figured I had to prove it to you. So notice that these two terms are here. Now that I've proven that my formula works, I can now use my formula. So we will do a plus b, which is x plus 5. And then I'll do a squared, which is 5 squared is 25. Sorry, a is x. I apologize. So it should be x squared. And then minus a times b, so that's x times 5. And then plus 5 squared. Okay, this line of work you can skip if you are able to, because eventually we know that we're going to flip these two and take the squared, so you just need to show this line right here. Okay. And this formula proves that there is actually no further way to factor, so no matter how hard you try, you will never have numbers that multiply to b squared and add to ab. So you could try it, but it won't work. Okay, so let's do this one now. This one doesn't look like there's a cube or a cubed. And so this is where you have to be really careful and use the GCF first if you are able to. Okay. So this one, let's see, what can we divide by? We can divide by 2, I think, is my only one. And then I can divide by s squared. So my GCF will be 2s squared. What am I left with now? 8s cubed minus 27. Okay. Now, the cubes that you should know, we know 1 cube doesn't matter because that's just 1. But 2 cubed is 2 times 2 times 2, which is 8. 3 times 3 times 3, which is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed, I think, is 216. And 7 cubed is 343. Check me if I'm right there, okay? So these two, you don't actually have to memorize them. You'll have a calculator where you can multiply 6 times 6 times 6, right? So here, let me write down that my a is now 2s, and my b is negative 3, right? Because negative times a negative times a negative gives me a negative 27. So let's factor. So I know for my blue portion of this, my difference of cubes, I'm going to have 2 parentheses, and I will first put down my GCF. Okay, so it'll be 2x, sorry, or s, minus 3. Okay. I'm going to do 2s squared. Now, this is not 2s squared, it's 2s times times 2s, which is 4s squared. Okay, you guys okay with that? Just make sure you don't miss that. And then plus, I know if this is negative, this one's positive. 3 times negative 2 is 6s, because I changed the signs. And then plus 9. Notice the last number is always positive, because negative 3 times negative 3 is positive 9. This is our final answer. Okay, but remember, GCF first. Okay, example 3, factor by grouping. We've already done something similar to this where we've split the middle. Notice there's 4 terms, right? This method only works when the polynomial can be written in 4 terms and something has to happen where the remaining factors after taking the GCF of the first two and the last two terms are the same. Okay, so the remaining factor, like what's inside your parentheses, has to be the same. Let me show you. So we can take out z squared and z squared, negative 4 and negative 4. This is really important. So if you have a negative in the front, you need a negative in your GCF. I don't care about this sign. Okay, this one will adjust depending on what you do, but this sign has to match. So the first one will always be positive, and the second one might be negative or positive, depending on the third term. So now, when we write our GCF, right, we have z squared on the outside and negative 4 on the outside. And the blue part is what has to match. Right now, all of our terms will match because I've designed problems to do that. Later in the chapter, it will not be this way. Okay, negative divided by negative is a positive. If you get anything different, that means either you factored wrong. Right now, the answer is you factored wrong. But later in the chapter, it would mean that you cannot use factor by grouping, and it's not factorable by grouping. You have to use a different method. Okay, I color-coded on purpose because now you are going to take your red and your red, or your GCF and GCF, to put them together, and then the blue and the blue go together. Please do not square this, okay, because when I distribute and FOIL it, I use z plus 5 twice anyways. 1, 2, right? And here, 3, 4. So we don't need to put a squared. I can also check if my degrees are correct or my exponents are correct because it's a degree of 3. So I should have 1, 2, 3 at most z's. Okay. Now it does say factor by grouping completely. In theory, we should be done. But you guys see how this is an a squared minus b squared problem? So we can keep going. X minus, oh sorry, not x, z minus 2, z plus 2, and then z plus 5. Final answer. Okay. Last 2 examples, and then there'll be problems for you to try. Now, so far, that's all been things that we have done so far, minus the sum and difference of cubes. Now, we're going to see what happens when our exponents are larger and there's no GCF to get rid of an exponent. You guys see how, like, there is no way I can divide by z's, because the first term doesn't have a z. Okay, so quick directions. I forgot to copy these up here. So make sure each factor is written in standard form with a positive leading coefficient. So first off, I noticed that this is a sum and difference of square. It's a difference of squares. See how it's an a squared minus b squared problem? But it's not in standard form. So what that means is I actually want to rewrite but now it's not a difference of squares, but it really is. So you're going to divide them both by -1. Okay, and this is a part where you wouldn't have to show your work. If you wanted to, and you recognize that you can jump to this, like if you could jump from here to here, I'm okay with that because that's such a easy thing that I want you to be able to do in your head. Now we need what times what is 81, and what times what is 16z to the 4. Well, we know that's 4 times 4, and you have to match them, right? Z squared, z squared. I don't know why I'm using z's. So at this point, negative 1 stays, and I have z squared plus 9, oh sorry, 4z squared, and then 4z squared minus 9. Okay. Now, is there another difference of squares? There is, right here. And so I'm going to have negative 1. 4z squared plus 9 cannot be simplified, but the second term can be 2z minus 3 and 2z plus 3. And it only works because 4 and 9 are both perfect squares. You guys okay with that? Okay. Let's practice over here. This one we can take out a GCF of 2, p squared, sorry. So if I'm taking out 2 p's from each one, can I also divide everything? Oh, I can. Oh, nice. Okay, I'm going to divide by 3. Now, I don't know about you guys, but I make a lot of mistakes in my work, so I'm going to write this in. Okay. And then I'll be left with p to the 4th, no, 6th power, sorry. I take out 2 of them, and I'm left with 6 minus 5p to the 3rd plus 6. All the p's cancel. Okay. Now, this is where it gets a little weird, because there is no special pattern for to the 6th power. It is a trinomial, though. Okay, so if you guys notice that if it was x squared minus 5x plus 6, I know that I could do x minus 2 and x minus 3. Are you guys okay with that? But the only problem is that it's not x squared. Well, if I split p to the 6th power and I did it as p cubed times p cubed, okay, then I could substitute instead of x squared, or instead of x equaling x, what if I set x equal to p cubed? Would that work? So then I would do x squared is 2 of them, right, p to the 6th. I could plug in here p cubed, and then this works, except in your final answer, instead of x's, we will put p cubed. So I have 3p squared, and then p cubed instead of x minus 2, and p cubed minus 3. Okay? And now, when I, as a math teacher, look at this, I know that if this number, or this exponent right here, doubles the second exponent, then I can split it, and it works. This method would not work if this was x to the 5th power and x to the 3rd. Okay, because when you split your first term, you have to have it equal to the variable exponent of the second term. I'm going to do a quick check. Is there a difference of squares? This is different, but there's no perfect squares. So we are done. Okay. So the rest of this is for you to practice. Please make sure you factor completely. I am truly out to get you on some of these. So you are going to try to show your work and get to the final simplest answer. For example, like this box one, not this one. Okay? We'll check our answers in class together, and let me know if you guys have questions in class.